Today we talk about 3D printing, okay? The technology of 3D printer, why we are using 3D printer, the application, the usage of 3D printer, and how we can implement 3D printer here at our job, okay? At our university or college. So, 3D printer, as you can see, the objective today is to use 3D printer, capabilities of 3D printer, and application of 3D printer. It started with in 1981, Haido Kodama of Nigoya Municipal Research Institute, first published paper outlining 3D printer. It was in 1981. Later on, 1984, Charles Chuck had a 3D system developed first prototype 3D printer, and he called it serial lithography. Serial lithography now is the STL file format widely used now. Now even this machine works on STL file which this man created. Okay, serial lithography technology. Okay, so if we ask ourselves, why do we need 3D printer? Why it's important? Why the 3D printer important? Who can tell me? Why do you think it's important? Prototype. This is exactly. We need a prototype. We need a sample. See this part of like bracket or something. We need to see it as a 3D printed part, plastic, cheap process to make it before we go to advanced manufacturing process. Because part like this, you might buy it from the mall like 4 dirham or 5 dirham. But if you want to manufacture this mold, like this shell, you need to manufacture this mold that contains this one shell. And this mold, do you know approximately how much the cost of this mold? Maybe 300,000 dirham, 400,000 dirham to get this. Because this is not an easy process. Before I worked, before my first work in 2011, I worked as mold designer. So this is my area, injection mold design. Very difficult technique, very difficult, because you need to care about the quality, where to put the metal, where to put the plastic, how to eject the plastic after you mold it, how to make the cooling for the product, okay? And if you look inside the mold, this is what you see inside the mold, all these metal parts inside the mold. So imagine if you want, as an example, if you make shell and you send it to a customer and he said, you know what, I don't like this shell. you spend a lot of money making this and he doesn't like it. So that's why the idea became now to make a prototype, okay? That's why we are using prototypes. So all these 3D printer. 3D printer, good alternative, is used for manufacturing, create model or prototype. Okay, all the things you see here are prototypes, okay? Are samples for things like this one. See, sample. It can move. If this printed out from the 3D printer, you don't have to fix anything. It's assembled also. Okay, this is sample. This is the gyro. Also, it can rotate. Done by 3D printer. I don't need to assemble anything in this one. I just printed layer by layer and it moved by itself. You can show the concept.
Can't we print final result, final product?
You can change the material. Now we are using PLA material. PLA is used for prototype. It's a little bit fragile. There are some other material like ABS or polycarbonate, PC. Okay, they are used in the industrial brand of 3D printers. There are 3D printers like the wardrobe size. This is for industry. They are using durable.
So it's printing at the same time, the one that rolls like here now, yeah?
Now it's printing
at the same time,
layer by layer. See, and it's also print the spaces between, you know, here the thread, there are spaces in the thread here. It also the printer will leave a place where it has to move. See here? I am printing the same wrench. This is the same wrench, okay? So this is 3D printer. We call this 3D printer is additive manufacturing process because in the past they used to have subtractive manufacturing process. The difference between additive and subtractive, this is raw material, you remove and you get it. This is subtractive. While the additive, like 3D printer, you have raw material, but it's not block. It's like powder, like rock, and you are creating the part. Okay? I have here videos showing you the difference between subtractive and additive. This is additive. As you can see, layer by layer. By the way, this one is the same as this one. I printed, this is my video. Okay? So this is additive. It built this one layer by layer, layer by layer.
What about the colors?
This one's sprayed.
Oh, okay.
So sometimes these are without any color. These are like you buy filament, like this is yellow, this is gray, this is blue. But for other things like this one, I just spray. Like this one, I spray. This one, spray. Star Wars. This one, like Pokemon character. Print. Okay? So this is additive, this is subtractive. Okay? The other example of subtractive, like CNC machines. See? This is piece of wood. Okay? You will be amazed about the final results here. See, this one 5-axis CNC machine. But I wanted to look at amount of waste created. See here, if you look again, here. See down,
Yeah.
amount of waste. Because this is subtractive material. You have a block and you remove from the block. Okay, so you will end up having an object, a 3D object, but you are wasting a lot of material. That's why 3D printer has more advanced in this field. Okay, so how to start printing? If you ask yourself, should I be familiar with 3D model software? Maybe I don't know how to do a software. It's not about this. Either you can model in the 3D software. So this is number one. You can model. Actually, this one is project for our students here. He came to me, approached me, and he wants to make like, you remember in the project it was for the petroleum. Yeah. I forget the name of this project, and he approached me and I showed him how to build this, how to create it, and he built this outside. This is one of our students. Okay? So this is using 3D modeling software. You can also do scanning. See, this is scan myself. Can you see here? I will increase the volume a little bit.
Welcome هي الموجة هناك دي.
I did for myself 3D scanning. Scan.
How did you scan yourself?
I used like softwares, I used different images, different angles, but this is just basic. If you buy, we are buying actually 3D scanners. So this is, as you can see, scan. Now what if you don't know how to scan, you don't know how to model? It's okay. There are a lot of websites that give you free software, free files in format that's printable. Just you Google it. As an example, what you want. So what's your subject? In art, engineering, geography, history, language, math, science, or based on grades. You are teaching from 6 to 8, you are teaching from 9 to 11, university. There are a lot of files. All these robots and all these files are free to download. And they are printable. They are modeled in a way that it could be printable. You don't need to modify anything. You don't need to have to be experienced. You can, as an example, you have an idea, you come to me or come to anyone who has a 3D printer, tell him this file, please print it. That's it. And you can integrate it. See, you can have the motor, have the, if you want to make a drone or a remote control car, just bring the board, bring the component, make them together, and you will have it. And this is, as you can see, artificial hand. Okay? So as we can say, this 3D printer, how it works, you have a 3D model, the software will slice the 3D model into layers, okay? And then it will be printed layer by layer, as you can see here. See? Now it's called the 3D printer, but it's not moved 3D axis simultaneous. It's not moved. It's moved 2 axes at the same time. At certain point, it will move in the Z direction. Okay? So that's why, see? Now it's print in 2 axes, X and Y, X and Y. At certain level, and after it finished, it will move up and build again. So that's why this one is sliced. Okay? What we need to know, is it just easy? No, it's not easy. Also the slice software, you need to know the parameters. You need to, what's the extruder, what's the nozzle diameter, what's the retraction, what's layer you are using, how many, the thickness of the layer, the tips of the layer, 0.3, what's the first layer height, what's the first layer width, what's the first layer speed. You need to know about additional, if you want to add skirt, use raft, you want to infill, what's the amount of fill, what's the angle of infill, what's the support, you want to add support. Who can tell me, what do you understand from support? If I tell you, you want to add support, what do you understand from the support? Support material, yes. What do you understand from it?
It supports the shape.
It supports the shape.
Give the shape support in order to hold it together.
Exactly. Some of the parts are really critical to print, like this one. This one, can you see this tail? How the printer will print this in the air? It will come here. What's below this? What's underneath this? It shouldn't be empty. The printer prints support material until it reaches here. So every time, starting from here, when I see something like this, I say, oh, whoa, this is the bad thing I have. When my son asks me to print something like this. Because something like this, I don't need support. It's all on the way. It will come out print like this on one step. This one is tricky. It will consume time just editing the parameter. Because if you add a lot of support, you will not be able to remove it. It is stuck here. See here, if you focus here, you will find it. See here. Jump. قدرت تشوفها؟ See here. If it's difficult, it's okay.
Give us a
See? Here I can
Is it dry?
I can
The support of ASD. It's the new logo.
If you can see here,
It's the new
it's
logo,
little tricky.
and this is the support.
So
Nice,
this-
huh? Nice.
This piece under the tail is the support.
Yeah, no, the support actually has been removed. I cut it. So, as you can see, there are parameters that you need to take care of. Okay, and also there are challenges and fails. See, all these are fails. People they don't show you the other side of this one. Okay, you have layer shift. Sometimes without any reason, with just mistake on calculation, mistake in parameters. You have string, which is really disaster. When you are doing a circle, while the printer moves from this area to other area, instead of moving circular, it moves rectangle, like zigzag. Okay, so you have to worry when you are making this. You have to say, I don't want the movement to be zigzag in this case. I want it to be circular. Otherwise, you will get string. And if in case you want to remove this, you need like this plier. Okay, you need tools, you need pliers, and you need to really work hard. See?
This comes with the.
Yes, it comes with it. So you need to start removing, start having sandpaper, start having this technique. Because these, sometimes you have loose spaces in the 3D software. And these loose spaces, you will not be able to print it correctly or open faces. Okay, so you need to be good in 3D printing, okay, in the software. Okay? Also, these are other type of errors, okay? Sometimes, like the nozzle, you need to change the nozzle. This one comes with 3 small nozzles. This, can you see the brass one? It's underneath this one. This sometimes it's clogged or it's blocked, so you need to unscrew, remove it, okay? So as we said, after that we send it to the printer. We have different types of 3D printer. This one called serial lithography. We have this in image department. We have this 3D printer. But this 3D printer, to be honest, is for different application. This 3D printer. This is used for jewelry design, mainly. Because this 3D printer has very precision, more than this one, has more advanced in precision. Okay? Because this technology called FDM, fused deposit manufacturing. This technology, it melts the roll of plastic and it builds it layer by layer. This technology uses resin and uses laser and it's right. So all this immersed inside the resin liquid. Okay, so step by step by using laser ultraviolet, it doesn't require support here. So as an example, if I'm using the FDM, you remember I told you when you have overhang, you need support. If I'm using this thing or this thing, what's the amount of support I need to remove later? Okay, how can I get this fine finish when I remove the support? I will never, by using this technology. So this technology for different reasons, and this technology for other applications. We have also this technology, and this technology requires a lot of removing the waste. I have video for the previous one and for this one, but we will see how it will come in the presentation. Okay? This is the technology we are using now, which is the FDM technology. So this is the filament. By the way, you can buy any color. There are a lot in the market. You can buy yellow.
Can you change colors halfway through, for example?
Yes, yes. They have the capability to change. I can just stop from here and put and insert, and it will continue.
But you cannot combine them.
There are 3D printers now, desktop, cheap, like this one. They have dual extruder, dual, but not more than two, like two maximum they can have. But there are in the market that 3D printer that full colorful, but it's for industrial.
So then print as
But for the FDM, you are talking about FDM or different technology? No, 3D printer, if you are talking about FDM, there are dual extruder, two,
they
maximum.
work at the same time.
They work at the same time. They can mix colors. They can make gradients. I will show you now how I implement this 3D printer in our application. So this is how we do this. Okay. We started with 3D model. We printed this part, and this part has been printed. And now I showed my students how can I open the part and see from inside. Okay? Also, I showed the students what we call this part section.
Limited education, huh?
Mr. Hussam, can you manufacture this one?
See, I am sure. See. Now also, I show them the example, and now they can point to the example in the book, and they can visualize it. I hit them visualize it. Now instead of just visualize how it will look like from inside, say, no, they can have it in their hand and see how it look like from inside.
Did you print it two pieces?
I printed two pieces because if I printed one piece, it will not going to be removed. It will be hard for me. So I printed on the 3D printer two pieces. Separated. See here?
Is it easy to add like a cut like you did? You have a full piece and then you want to cut it in half. Is it easy to add the cut?
Yes. On the software, it's easy. See, I print like this. See, as you can see, they are apart. I printed them apart. But you have to take care of tolerances. What's the amount of tolerance you have to keep? Otherwise, they will not fit. So, and the tolerance is based on your 3D printer. So, as an example, for my 3D printer, until 0.2 millimeter, it can handle. I can let the fit. See? It will not fall down. Okay. Also this example. Can you see this example? This one, I asked the students to draw like top view, front view, and right side view. I want them to have graphic projection. Okay. So I printed this part, which is this one. Okay, and I asked them to manufacture this part. I have the third one here. I asked them to visualize it and draw it. See? This one, how they can understand. Also, in addition to that, I added grades. Like I in the grading box, okay, in the CAF file, I added just one column. I called it team project. This team project, the students have to take one drawing. Okay, and they have to work on it, make 3D models, make engineering drawings, and go print it outside. I told them, I will not help you. I don't know about this. Go help yourself. And this is the result. 1, 2, 3. All these are students' work. All this you can see here. All this are students' work. All these projects are done by the students. And I showed them everyone his grade. And if someone reduced grade because printing quality not good. Some of them, they have printed quality. Some of them, they don't provide engineering drawing. You provide the 3D model, but you did not provide top view, front view, right side view. So you will lose mark. Okay, and I did this for all my CRMs. 2830, 2831, 2832, 2834, all 4 CRMs in this semester, not this semester. Okay? And here are the parts. And I get more. Okay? Also, one of the students, he was inspired by 3D printer. So he told me, sir, I want to go into enroll to 3D printing workshop. I said, why not? And he showed me the picture, and he got a certificate, and he was happy by learning something. So he did this by himself. Thank you very much. Okay. In terms of education, you have in biology, you have geography, you have in physics, you have in math, in machine mechanics, you have for math, see, you can have these. All these are printed files. You have for art class, printed students, robots, variation of 3D printers available in the market. So, any questions? If you want to follow me.
Follow him in the Instagram, please. He has a very
So, any question about this one? About 3D printing, about the technology, about what
very
you've
good
seen?
I have how cost effective it is. Like you talked about the chair. Isn't you cannot do chairs. They're still doing mold for the chair, yeah?
Yes.
They don't-
See, I will answer your question. For mass production, it's not recommended.
No, only
It's
for
not recommended.
prototype.
It is the behavior of the plastic from injection mold totally different from rubber prototype. This one, the structure is built layer by layer, while the injection mold, it injects the plastic simultaneous at all cavity, one time. That's why the rigidity of the plastic, because I was working as a designer, plastic designer. If the mold did not fill some parts, we call this mold failure. So the mold, it filled one time, so the rigidity of the plastic more strong, of the injection mold plastic. As an example, this one, plastic, injection mold, it's hard. If I create like this in 3D printer, it will not be durable as this one. Injection mold is different. It is used for production, small component. If you are entrepreneur, you want to create something, you want to sell for your neighbor, you can support it a little bit, add ribs, like this one. I have part like this one. This one. See here? This one has ribs from the side. Can you see the ribs, the support columns? Can I show you? See this one here? This called ribs. This one and this one. If this one and this one not available here, this part will be broken easily. So that's why they support it with ribs. Okay, so we can manipulate, we can do these things, but for mass production, it's not yet recommended, based on my knowledge, and based on the desktop 3D printer.
Saying they're going to start doing 3D printing for their shuttle when they go to like Mars or whatever. So does that mean they can like use aluminum or stuff like that?
There are metal 3D printers, but still not yet for the customers. It's for like industry, for the militaries like this. There are 3D printed metal 3D printers. It exists. But I think maybe it's a company like Tawazun, they have one. But it's not for normal, customer. Any questions? Anything you need to know about this?
How much does it cost?
To buy desktop 3 based on the shape of 3D printer type. As an example, this one is like this size, like this. This one, the bit, it's 120 by 120 by 120, even less than this one. Desktop, very small. Okay, see the size of the filament. This is the filament. See the size compared to this machine. But see the size of this one compared to the machine. So this is not a big machine. This is also small, but this one's smaller. This one could be 700 dirham, 800 dirham. You can buy this one. Okay, but you have to expect what you are getting. in terms of capability, in terms of time, in terms of durability, like this.
I guess 4 or 5 years, your children, your kids will ask for 3D printer at all.
Yeah.
So how much?
But it's
Like how much?
Like this one for 1,000, you can get one.
1,900,
yes. Like this one, Ultimaker, we are going to buy, I think from Ultimaker, okay, this one, 15,000. This one very branded.
So what's the difference? More precision in that one?
More precision. The motor, the boards, it's not like very cheap. It's made of hard material, made of.
How big is
This
that?
one is fab. This one fab. We have it, as I said, in the engine department. This one, 20,000.
How big is this one?
This one, 300, 300, 300. Like 30 centimeter, 30 centimeter, 30 centimeter. We are going to have, I think, it will be from Ultimaker.
We have ordered the similar to
This one, you have this one also. This one, by the way, if you don't notice that this is delta, it's not XYZ. It moves like this. It's delta, not X, not what you call it Cartesian coordinate. This one, it's moved on delta. This one moves and it do like this. Different technology. Also, it's built layer by layer, similar.
Delta.
Oh, you did not see this one? No. I have to show it. Just make it in the lights. Up in the lights.
Well, make a few things for us. Give me this.
That's exactly.
So are you done?
Yes, I am done.
Yeah. Thank you so much, Hussam, for this workshop. I think we have all enjoyed the 3D printing. It was not clear for most of us actually, the technology, but now it is a little bit, we got idea how things, and the setup that you have provided is very nice. I like it personally, and I don't know about others, and it is now the time, if you like, to come here. We will continue these seminars. If you have any idea, if you have also anything to present here, we welcome you. So I think we will continue this in the fall semester. Thank you again for Hussam, and it is the time for to see. Like this, you can move it like this, you can move it like this, and it's remain opening forever. There's no limit for this one. It will not stop. Can you see this one? If it's not appear here, I will pass it to you so everyone can see.